Backtracking is a idea. It's actually a applications that has been widely used in softwares. You can take a look at the backtracking histories here. If you ever used a word editor, even on Chrome too, you can undo, right? There's a list of undo. So in order for any computer to remember what you just did, let's say if you did a whole bunch of events by clicking a mouse button, and after that, you press the enter key. And then after that, you press the A key, so on and so forth. Every single one of these events is recorded on a stack internally by your software. Let's just say clicking a mouse is event number one, pressing the enter keys 2 and 3. So you're going to see something like this, 1, 2, 3 on a stack. When you're done pressing the A key and decided, maybe can I undo this? So in order for a computer to do that is to look into stack at runtime, popping information off of it to kind of backtrack, right? So by popping off of 3, it now it's on top of 2. Top means the very top of the stack. So if you pop number 2, then it gets to 1. The idea is akin to, for example, that you're walking into a forest and you take a loaf of bread with you. You will leave a breadcrumb everywhere you go inside the forest, and these breadcrumbs together allows you to backtrack. This is what we meant by backtracking. Popular applications in CS, and it makes use of stack. In addition to undo, there's also redo. Redo is exactly the opposite of undo. Redo allows you to undo the undos. This is pretty much the premise behind this problem, knowing how backtracking works, making use of stack. And the other one is keeping track of your redos and undos in both directions. So we're going to make use of 2 stacks in this case to keep track of one undo, another stack to keep track of a series of events associated with redos. So that's what we're going to do in this problem. And as usual, before you get started, make sure that you have problems in a compiled form. My recommendation is to make a copy of this. Go to any online IDEs. So you're going to have to modify this. And first of all, your homework assignment 2, and since there's only one problem, is homework assignment 2_1. So you're going to have to modify this as a main to kind of make it compile. This is whatever you have here in line 4 is totally up to you. If you don't know what an API documentation is, go back to your syllabus or go to homework number 1. You will see the example of what an API documentation is. You can actually have your entire documentation on line 7 or line 9. It doesn't really matter where you stand. So as you can see that the main class is a public class. Now this nested class that is your solution class, which is what the bulk of your work should be in, it's not a public. So this one has actually a default scope. You don't want to put public here because if you put public at line 8, it's not going to compile. So in order to get nested class to work, the second class should not have a public in front of it. Anyway, so this is already written for you. So what you need to do is make sure that your code here contains all of your logic. This one returns a Boolean. So I'm just going to, for compilation purposes, I just want to make this compile. I'm just going to say return false. Hit run. You have the entire bare bone to start with, and this is platform independent, which means it will run on any machines with Java runtime. I'm using Java 10. For this class, you're allowed to use Java 8, 9, 10, 11, so on and so forth. Do not use anything prior to Java 8 for this course. And now you have your bare bone, your shell, your templates ready to go. Let's take a look at the problem. Assuming that we're naming each of these events, no matter what they are, by the numbers 1, 2, and 3, if suppose that the user goes to the above events 1, 2, 3, 4 without undoing them, this is how you would represent it. So first of all, you have this event sequence: push 1, push 2, push 3, push 4. The user simply just keep pressing, going through these events. You have 2 stacks, both of them represented by array. This array pushed has 1, 2, 3, 4 in it. However, event popped has nothing in it because you haven't popped anything. So event push is kind of like your redo. Event pops is an array for storing all of your undos. So one of them is for redo and one is undos. Let's just move on and see what exactly are we asking you to do. You're to create this method inside the solution class, and that method is called isSameSequence. Please do not spell this on your own because sometimes students misspell something. This happens every semester. And this one takes two arguments coming from the outside. One of them is the events push, and the other one is the events pop, similar to what you have here. If you have a push, 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 and then pop, this is how it is represented. Both of these push and pops arrays represent this event sequence in such a way. 1, 2, 3, 4 being all of the pushes, and the pop stack represent the pop event. So in this case, there's only one pop event. So you store number 4 inside this. Let's just move on and illustrate with more examples here. If you have this event sequence that calls for push 1, push 2, push 3, and then you pop 3, then that 3 is gone. But you want to push 4 and then pop 4 again. Again, 4 is gone. So what you have left is 2 and 1. So you ended up popping 2 and popping 1. So this is just an example of an event sequence. So if you were to draw a vertical stack like we did before, the very first one that gets in is 1, the second one is 2, and the third one is 3. So now we're here, push 3. After push 3, you have pop 3. So I'm going to use a different color to represent pop. So now you're popping 3. You have only 2 and 1 left. Stack is last in, first out. So you always go from the top. The next one is you push 4 and then pop 4. Since 3 is gone, you're pushing 4 in. So push is in blue. So I'm going to put 4 here. So as soon as 4 is pushed in, you pop 4 again. So I'm going to use the red color to represent pop. So I'm popping 4 again. Your stack is still at the original height. So what you have left is just 2 and 1. So this is going to take out 2, and this is going to take out 1. So eventually your stack is empty. So this is a visual representation of what's going on here. If you were to represent this one particular sequence in the push and pops arrays, it'll look something like this. Find out all of the pushes, 1, 2, 3, 4. These 4 represents 1, 2, 3, 4 in the push event. And then you have to go through the event pop. Now this is in the order. So you're going to have to say, where is the first pop? The first pop is 3. So you're going to have to write 3 in here. 4, 2, 1. 4, 2, 1. So as you can see, both events pushed and events popped are an array representing the sequence of events in the orders of all of the pushes and in the order of all of the pops in chronological order. So this is how you abstract pushes and pops. So essentially there are a whole bunch of redos in this one and a whole bunch of undos in this one. So you're separating redos and undos essentially. So hopefully this is clear. Your method is going to be called upon with 2 arrays, 2 integer arrays. One of them is all of the events that are pushed into this sequence of event, and the other one is all of the events that are representing pop in this sequence event. So you're asking to see if these 2 chronological redos and undos represent a single event sequence. Both of these, events pushed, events pop, represent this entire sequence. Examples. This is one example where that function is going to return false, which means both of these, events push and events pops, they do not represent a single event sequence. This says you have push 1. We can pretty much just draw this out. So I'm using red. So basically you have 2, and then you have 1, and then you have 3. So this is all of the pushes that end up with these elements on the stack. You have this event popped, starting with 3. So you're popping 3, but after that, it says you're popping 2. Once you pop 3, the next one is 1, given the sequences. So there's no way you're going to be able to pop 2 before 1. Stack is last in, first out. So 1 has to be popped before 2 could be reached. So this 2 redo and undos, they do not represent a single event sequence. So this is impossible. So the output is false. Now, if you go to this is the result of this particular sequence here. So basically what you're asked to do is write that method that takes two inputs. One is all of the pushes and the other one is all of the pops in their chronological orders, and see if both represent coming out of event sequence. So it's kind of like working backwards. I'm giving you the result of this set of pushes instead of pops, or this set of undos and redos. And then your job is to see if this actually came from the same, both of them came from the same event sequence. We're still talking about stack here. So think about this. How would you construct same event sequence to account for these chronological orders? So think about that. A couple of constraints and assumptions. Size of the arrays for push and pops, redo or undos, they're both the same, which means you cannot have one array with 20 elements and the other one with only 5. No, both have the same length. So that's the premise. It's kind of different than we have here. This is just to give you some of the backgrounds associating with the event types here and there. And the real examples is actually here. So you can see that your two inputs here are of the same length. 3, 3, 1, 1. So that is the first assumption. And second assumption is events push is a permutation of pops in values. This means that both input stack have the same event numbers but in different order. As you can see here, 1 to 3 is the same as 1 to 3. So you don't have 4 here, you don't have 5. They're just in different orders, but they all, both arrays encapsulate the same series of numbers, but they're in different orders. And the other one is no repeated value in their stack. So you cannot have 2, 2, or 5, 5, or 6, 6 in there. They're all different numbers. Both stacks is between the size of 0 and 100. So you can have an input of size 50 for each of these. You can have a input of size 99 for each of these, but the size cannot be more than 100. You cannot have empty stack too, because it says both stacks length has to be at least 1. So that's what this is. And the same thing with before. I would not give you any test cases that's gonna have you perform pop on an empty stack, because in this case, you would be getting an empty stack exceptions. For this problems, you may have to use this. If you use Java util stack, then you're definitely gonna get into empty stack exception when pop happens. You don't have to worry about catching that exception and things like that. Error handling is optional for this course. I just want you to focus more on the data structure side of things, the mechanisms. Whether you want to build your own stack or use Java util stack is completely up to you. My recommendation is just use Java util stack. It's a lot easier because it's already built for you, and then you can make use of the existing operations that are part of a particular stack. So there is no need to modify your input stacks though. They can be read-only. You don't have to modify your input stack to change anything inside to get this to work. Read-only, meaning events pushed and events popped, they're simply being available there for you to read from. You don't need to change anything inside. You submit one single file, and this file is worth 10 points. Let me know if you have other questions. Please observe the due date for this problem.